Hey guys, welcome to the help video for perfect points and finding slope. You clicked on this red button I see, or you've subscribed to the channel, and you see that there is a walkthrough video. So welcome to that walkthrough video. Let's get started. Our first slide says to sort the cards by types of slope. Remember, for slope, we got positive slope. That's going to go up from left to right. Oops. Negative slope, that's going to go down from left to right. And then you have zero slope. Zero slope is a flat line. Okay, so anything that looks like this going up is positive. Anything that looks like this going down is negative, and then zero is completely flat. Now, our graphs, we always want to look from left to right. Okay, so some of you guys are saying, well, if you go the other way, if you go back, then you can go up. How's that not positive? We always look at our graphs, read our lines, our functions from left to right, just like we do words and sentences and how we write. Okay, so left to right. Up is going positive. Down is negative. Okay, so our little card pile here, let's go one by one. That is a flat line. That is zero slope. There is no incline. Slope, remember, is your incline. Okay, this one does have a slope. It is going from left to right. It's going down. Another flat line. That's zero slope. Now, this one's not completely flat. It's pretty flat, but you can still see that it's going down ever so slightly. So that's negative. Okay, this one from left to right, it's going up, positive, our first positive card. Here's another flat line, zero. From left to right, this one's pretty steep. This one from left to right is going down pretty fast. That is negative. From left to right, see, it's going down, negative. From left to right, even steeper, it's shooting straight down, also negative. So there's 5 cards on negative so far. Left to right, very steep. That one's pretty similar to this one, but it's just the direction, right? So this is negative, this one's positive. It's climbing up. From left to right, pretty flat, but you can still see from left to right, it's moving up, positive. From left to right, this one is also moving up, positive. Okay, there you go. So there's 4 on positive, 5 on negative, and 3 on zero. Okay, what do we know about slope? There's nothing for you to do on the slide. This is just a quick recap. To measure slope on the coordinate plane, we're going to measure the distance between 2 points on a line looking at our vertical change, aka rise or fall, and our horizontal change, aka your run. You're going to select 2 points where you can clearly identify the x and y coordinates. So in class, we talked about perfect points. This right here is a perfect point because it's perfectly on the grid line of your coordinate plane. This little fella is not, he's levitating in that box. That is not a perfect point. And the reason why we don't want to use something like this is because the x and y values, x and or y values are decimals, and we're not confident on what this could be. For example, if this was 1 and 2, okay, this point's between 1 and 2. It could be 1.2, 1.1, is it 1.3? I don't know, because that's not a perfect point. So we want to find perfect points on your function that are perfectly within those grid lines. Sometimes they give it to you, sometimes they don't. For this assignment, it's going to ask you to find your own perfect points and mark it using this little dot. So I'm going to go ahead and drag my dot right here to this perfect point that I see on top in the corner. There's actually another perfect point right there. See how it's perfectly in the grid lines? Those are the points we're going to want to use when we're finding slope. All right, so I think we have 9 questions where we have to find 2 perfect points and then calculate the slope of our line. Okay, our slope is our rise over run, but like I said in class, this rise could be a fall depending on whether that's positive or negative slope. And then we're also going to write the equation. There are many perfect points. There's not only 2, but you just need to find 2 that are side by side in order to find your slope. So your 2 that you find might not be the same 2 that I find. All right, so find your perfect points. I see one in the origin right here, which actually is the characteristic for proportional graphs. So if all of these are proportional functions, they should all include 0, 0. And then my next one I see, kind of trace the line and see where is it. See how that's not perfect? For that, let me move my dot. You see how that's not perfect? Got this little corner jutting out. It's not perfect. Just move your mouse up. Fine. That one's not perfect. Oh, there it is. right. Whoops. Didn't mean to move that whole box. Right here. That is the next perfect point. Now there's another perfect point. I'll go ahead and mark for you just for fun. The other perfect point is right here. Now it does not matter which perfect points you find as long for your slope. As long as they are truly perfect points, when you calculate, when you find out your rise over run, your slope is going to be the same no matter what. Just make sure you're moving from left to right. Again, just like how we read, we write from left to right. We're going to look at our function from left to right. So if we go from the leftmost dot, I'm actually not going to use that dot. Get that away. From this point to this point, because we're moving left to right, what is my rise? What is my run? How far do I have to rise up? 1, 2, 3, 4. What is my run? 1, 2, 3. So rise 4. So up 4 over 3. Your rise over run is 4 over 3. There you go. Now we have to walk in our grid lines. You can't just go straight from point to point diagonally. You can only walk on your grid lines. If our rise over run, or our slope, is 4 over 3, remember this is also m. Our equation is y equals mx. And what we're replacing is this m with our slope. So our equation for this function is y equals 4 over 3x. Okay, I'm going to move pretty fast because videos you can always watch again. Here's our next one. Oh, the first thing I see is that this is going down, right? This is a negative slope, which means we don't really have a rise. We have more of a fall, what I call a fall. I'm going to go ahead and find my perfect points. There's one in the origin right here, and I know I'm moving from left to right, so I'm just going to go down until I find my next perfect point, which is right here. Boom. If you wanted to keep going, look, there's another perfect point right here. So what's my fall over run? We're not going up, we're going down. How far down are we going? 1, 2. So down 2 and over 1. And you can see that this works for every perfect point. To get from point to point, it's down 2 over 1. If I started way up here, you could also see it's down 2 over 1, down 2 over 1, perfect point. Down 2 over 1, perfect point. Down 2 over 1, perfect point. It's like a staircase. So we're going down 2 over 1. Now, this this 1 right here, this divide by 1, it tells us that we do move over, but all whole numbers can be put over 1. Because if we divide anything by 1, it's just still that number. So our slope is negative 2 over 1, which is the same thing as just negative 2. We don't have to put whole numbers over 1 unless we need to. So our equation for this one is y equals negative 2x. Next, this is back to positive slope. I'm going to go ahead and include the origin, and then I'm going to just trace my line up until I find the next perfect point, which is right there. Quick one. So what is my rise over 1 run? Here's my next point and my next point. And this slope is going to be the same. It's going to work for every single point to point. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, the whole way through. So our slope is up 1 over 1. 1 over 1 is just 1. Y equals 1x. And in fact, you don't even need to write the coefficient of 1. We also don't see 1 as a coefficient. It is implied that if I just have an x, that's 1x. Here's another positive slope. I'm going to plot my origin. Then I'm going to use my mouse, trace with your eyes. Where's the next perfect point? It is right here. Ooh, it's pretty far away. But that's okay, no problem. How do I get from leftmost point to the right point? We have to rise up. 1, 2, 3, 4, 5. Our rise is 5 and over 1. Remember anything over 1? We don't need to really write that. Our slope is 5 because 5 divided by 1 is just 5. Our equation is y equals 5x. This is a negative slope. We are going down. I'm going to go ahead and use the origin as 1 point. Now I'm going to trace this line, this function going down until I find my next perfect point. See how that's in the middle? That is not perfect. That one's closer, but there we go. Moving from left to right, what's my rise over run, which is really my fall. I'm going down this time. Down 1, 2, 3. Down 3 over 1. Down 3. That's why my 3 is negative, because we're moving down. Anything over 1 is just itself. My equation is going to be y equals my slope, which is negative 3, x. Back to positives. Put that dot on the origin. Trace your line up till you find the next perfect point. See, that's in the middle, in the middle, in the middle, right here. There it is. We're always going to go from left to right. My rise, I'm going to go up 1, 2. And I'm going to go over 1, 2, 3. My rise is 2. My run is 3. My slope is 2 over 3. You can actually see again that if you found another perfect point, it's still going to be 2 up 2 over 3 to get to the next perfect point. My equation is going to be y equals m, 2 over 3. M is your slope, x. This is a negative slope because it is going down from left to right. Let's go ahead and drag our points. I got the origin, so all of these functions are proportionate because proportionate functions are straight lines that touch the origin. I'm going to trace my arrow going down. There's my perfect point right here. Okay, what is my rise over run? I'm going down 1, so negative 1 over 2. Down 1 over 2, so negative 1 over 2. That's your slope, that's your m. Your equation is y equals negative 1 over 2 x. You know, I thought of something important. Some people do follow the lines and they want to do this. They want to say, okay, it's 2, 1. Okay, but that is a run over rise. We cannot run. We cannot. Do you remember that picture of the guy picking up his foot? Rise over run. You need to pick up your foot before you can move forward. So we can't just levitate forward. We cannot move forward. You have to either go up or down first, then left and right. You rise or fall first, and then over. Okay, so don't get confused with that. If you swap these numbers, your whole answer is wrong. It's rise over run, not run over rise. Rise over run. Here's our next problem. Here's the origin. Find your next point, your next perfect point, not any point. There we go. And our rise over run. We got to go up. Don't go over. You got to go up first. This is also called, if you go way back, actually here, let me go back. In the beginning, one of the slides said it. Right here. This part. Slope is your vertical change over your horizontal change. You know what this word vertical means? Vertical goes up and down. It's your change in your vertical line over your change in your horizontal. Horizontal goes left and right. So you've got to move up and down on our coordinate plane before you move left and right. That's why we say it's rise over run. Rise over run. Or fall over run. Okay, so don't do the opposite. Lots of people do the opposite. That might be one of the most common mistakes for finding slope. Are we on the last problem? I think we are on the last problem. Okay. Last problem's positive slope. Rise, 1, 2, 3, over run, 1, 2, 3, 4. Our slope is 3 over 4. Our equation is, I don't know why I have two boxes here, y equals 3 over 4 x. Okay. I hope that helps. I know I ran through that super fast, but hopefully everybody has a good sense to know that you can pause the videos. You can even slow the videos down. You can change the playback. So I slow down a little bit. I try not to make these videos too long, so I speed through them, but watch it again. Pause it as you're completing the assignment. Pause it, check your work, watch it again, or let me know if you have any questions. All right, guys, see ya.